Hello everyone, this is Mr. B with Algebra 2 Notes 3.1, Graphing Systems of Equations. Let's jump right into it. Let's see, first thing here, system of equations, two or more equations with the same variables. That's pretty much it. To solve a system of equations, one way is to graph both equations. The intersection is the solution. All right, so let's try that now. This one is not going to come out perfect. So when that happens, I'm just looking for your kind of an estimation. We'll find out exactly how to solve a system of equations like this, where their intersection isn't incredibly obvious. But that's next week, so don't worry about that yet. First off, let's solve this equation. So first thing I'm going to do here is put this into a form that I can more easily recognize. So I'm going to put this in slope-intercept form. That's usually the easiest one to get to, so we'll do that. I'm going to subtract x from both sides here. That'll give us negative 2y equals negative x. That'll divide both sides by negative 2. That will leave me with y equals 1/2 x. So we know that the y-intercept, that's plus 0, really, if you want to think of it that way. It's right here, and the slope is positive 1/2. So up 1 over 2, up 1 over 2. Let's see. I'll use my straight edge here to graph that. Let's see. There we go. And this next one here, much more straightforward. Just subtract x. We'll have y equals negative x plus 4. So our intercept is positive 4 right here. And our slope is negative 1. So down 1 over 1 looks something like, oh, that's a little bit off. Let me try that one again. Let's see. There we go. So it'll be a little bit more accurate, I think. All right, so the intersection that we're looking for is right there. That value of x and y, these two lines equal. We'll get the same output with the same value of x in a sense. So I'm going to just kind of estimate this one here. It doesn't need to be precise. I'm going to say that that x is probably 2.75 and the y is 1.25. Again, when it intersects not exactly like this, I'm not looking for something exact. Not at this point, at least. For instance, if we had a line that was with a slope or with the intercept of positive 3, we would actually see them line up really, really nice and cross right at that. We would know that that point, in this case, would be 2, 1, but we don't know that for these two lines, this system of equations that we currently graphed. So let's jump down onto the next one here. This one, I believe, does work out pretty nice. So a club is selling copies of their small community cookbook to raise money. The printer's base fee is $20, and each printed book will cost an additional 20 cents. If they sell the cookbooks for $1 each, how many cookbooks will they have to sell to break even? So the first one that I'm going to do here is just write an equation. First for the cost of everything. So y equals, the base cost is 20. So I'm going to have plus 20 here. I know that'll be my basically y-intercept. And the slope is 0.2. That's how much every book costs. Let's see. 0.2 really just equals 1/5. And that's easier to think of in terms of slope. So I'll do 1/5 x. And for the profit of these books, well, that's just y equals, you can think of it as 1x. They're gaining $1 for every book that they sell. So that's that. I'm just going to say yx for now, or y equals x. Now we just graph these out. For this one, I'm going to count up in increments of 5. So 5, 10, 15, 20, 25, 30, 40, oh, that's 40 and 50. There we go. 5, 10, 15, 20, 30, 40, and 50. You don't need to fill in every single one as long as we know clearly what the scale is. This first slope, the intercept is at 20. That's where it's going to start. And it's going to go up 1 for every 5 that it goes over. So we'll go all the way over here, right there. Let's graph that out with a straight line. There we go. And y equals x, it's pretty straightforward. Just slope, the intercept is 0, slope is 1. So we're going to have a line that looks very much like that. I didn't draw it perfectly, but the intersection is right there at 25, 25. Sometimes writing out a graph like this is going to be very beneficial in terms of kind of checking your work or visualizing some data that you have in the real world. So we're kind of looking at it here. On this next bit, just a bit of vocabulary. I'm not going to test or quiz you guys on this, so don't worry about understanding this exactly. I just want you somewhat familiar with the terminology. So, consistent, a system of equations that has at least one solution. And independent, let's see, it has exactly one solution. These equations graph intersecting lines. That makes sense. Just like we did up here and even further up here, they intersect at one point. You might think that that's really the only option, but there are two others. The next would be dependent. It would have infinite solutions. These equations, rather, graph the same line. So these, I mean, they're going to equal each other. You might see them written in different forms. I'm trying to think of one. I mean, here's an example: y equals x and y minus 1 equals x minus 1. I mean, if we add 1 to both sides, we'll see that, yeah, they do actually graph the same line here. No, that's pretty much it. They would graph the same exact line. So any value of y, you could still solve that with some value of x later down the line. All right, an inconsistent would be a system of equations that has no or zero solutions. I'm going to write 0 solutions. Inconsistent systems of equations, wrote equations twice, don't know why I did that. Inconsistent systems of equations graph parallel lines. That's everything for these notes. If you do have any further questions on these, please let us know in class. I'm sure that I've mentioned it in class, but we are wanting homework to be done before the next class so we can actually spend some time discussing homework, going over some of the trickier problems, and coming to a better understanding together as a class. All right, we will see you guys there.